Hey everyone, welcome to the second lecture video for Unit 5. Today we're going to talk about forestry and what forests are, why they matter, how we use them, how we can protect them, and how we can manage those resources in a sustainable way. So in the second unit we learned about ecosystem services, and if you look at all the different services that forests provide and you can put a monetary value on each one, we find that forests are worth almost $1,000 per hectare per year, which is a lot. A lot of that's coming from supporting and regulating services, right? But also raw materials. So in Connecticut, there are over 700,000 hectares of forest, which means that we're getting about $700 million worth of value out of these forests every year. Meanwhile, in California, there are 13,334,626 hectares of forest, meaning that they get over 12 billion, almost $13 billion worth of ecosystem services from forests per year. So I guess you could say that money really does grow on trees. But the point is that forests are important, and we should protect them, we should value them, because they provide us with a lot of services. So the main problem facing forests these days is deforestation. When I say these days, I mean for the past couple hundred years. When colonists first arrived from England, there were lots of trees all around the United States. But since then, there's very little forest left in the country that hasn't ever been cut. This isn't a map of the forest that remains. This is just a map of forest that has never been forested before. So deforestation is a problem, but it's also been pretty necessary for our development as a nation. And there are a couple different ways that you can forest for trees. The first way is selective cutting, which is exactly what it sounds like. You go through and you remove a couple singular trees, or maybe just a specific certain species of tree or a specific age of tree, but you're not cutting down all the trees in the area. You're just coming through and taking specific trees, and this creates a more sort of age diverse ecosystem and perhaps even a species diverse ecosystem, which makes the community a little bit more resilient. Leads to less erosion and less loss of biodiversity than clear cutting, which I will talk about in a second. The problem with selective cutting is that the building of the logging roads can fragment habitat. It's a bit more costly and more difficult than just going through and cutting down trees, and you only end up taking high quality trees, which leaves behind all sort of the crappier trees, right? So you're sort of devaluing the ecosystem in that way. And here are some pictures of selective cutting, going through and just cutting down a few trees here and there, not cutting down all the trees, trying to preserve some of the ecosystem. And that is totally in the opposite end of the spectrum of what usually is going on, which is called clear cutting, which is when you go in and you literally cut down all the trees in an area. And so this is going to have much bigger impacts than selective cutting, but is much more economically viable. So if you've got a whole stand of trees, you go through, you cut them out, they grow back, you tend to them, and then you cut them down again. This is really economically efficient. It's easiest, and it's pretty easy to replant them as well. You can see some Douglas firs being replanted here. This is done a lot with Christmas trees, because those are cut down every year. But there are a lot of drawbacks to clear cutting, as you can imagine. First of all, it leads to a severe reduction in biodiversity. When you cut down this whole patch and you've started secondary succession, basically, right? Which we know takes a long time. And that's going to favor our selected species. So as species start moving back into these patches, there aren't going to be as many species available to contribute to biodiversity. Additionally, you might be if you're cutting down all the trees in the area, you might be cutting down other species that you don't end up using, whether it's bushes or vines or even other trees. I like to think of it like bycatch, like when you accidentally catch a dolphin in your tuna net. It also leads to habitat destruction and fragmentation from the logging roads. Additionally, the lack of trees means that there are less roots holding the soil together, which is going to lead to an increase in wind erosion, and those roots aren't going to be able to cycle nutrients. There's going to be less organic matter to decompose. It's going to lead to a loss of soil nutrients. The loss of roots also means that it's more prone to water erosion. So as a rain comes through, it's going to start eroding away the topsoil, and that topsoil is going to end up into the nearby streams or rivers, which is going to increase the turbidity of the water and deposit lots of sediment into those streams. which can ultimately lead to mudslides and floodings if it gets severe enough. It's also going to increase the temperature of the soil and the streams because trees provide shade, so they regulate their local climate by cooling off the ground and the streams, and without them, the sun is hitting directly, so it's going to increase the temperature of the soil and the water. And like I said, recovery via secondary succession is going to take a long time. Not as slow as primary succession, but it's still pretty slow. And here's some pictures of some of the impacts. We see stream sedimentation here, this brown murky water, and some landslides that have occurred due to deforestation, the lack of soil structure. Now, one of the reasons that clear cutting is so popular is because of these things called tree plantations, which basically is when foresters come through and they plant a single tree species that grows really, really fast. This is what it's called a monoculture because you're only growing one species of tree, and so you grow them and then you quickly cut them down once they're old enough, and then you replant them, and so you end up with these communities of trees with really low biodiversity, which is going to decrease their ability to cycle nutrients throughout the soil because you've really only got one species. So you don't have like nitrogen fixers or anything like that. And there are lots of other reasons why biodiversity is low as well, as we talked about in Unit 2. There are some. These are some case studies. You don't have to know about these specifically, but I want to talk about these because they're pretty relevant in terms of deforestation as well as these massive monocultures that I was just talking about. And this is happening in the rainforest in some areas of South America where they're growing soybeans for mostly animal feed, and in areas of Borneo, Indonesia, Malaysia where they're growing palm oil. Now palm oil, I'll talk about that first. Palm oil is found in pretty much everything. If it's processed, it's got palm oil in it. Candy, beauty products, shampoo, some types of detergent and ice cream and stuff. So you can find palm oil in almost everything. And you can see the palm plants here. You see this massive monoculture compared to sort of the biodiversity of the rainforest ecosystem. You can see, look at all this mist from the transpiration of these trees. You don't see any of that here. So you can notice changes in the local climate because of this monoculture. And these rainforests, particularly in Borneo, Indonesia, and Malaysia, where palm oil is mostly grown, are one of the last wild habitats for orangutans. So their population is threatened because of this palm oil industry. Here's another picture. You can see the massive monoculture. These are all palm oil plants, palm plants. And you can see how it leads to a severe reduction in biodiversity, right, compared to the area around it. And like I said, these orangutans who live in this very small niche are losing habitat due to habitat fragmentation like this, but also just straight up loss of the habitat. On top of that, a lot of the palm oil industry is there's a lot of abuse of humans within the industry, not only physical abuse and working long hours and poor working conditions, but also lots of cases of sexual abuse as well. So it's a very shady industry, and most of that palm oil farming is happening in Malaysia and Indonesia. So when you buy products, look for products that have check for palm oil on the label and look to see if they have a logo, something like this, that says that it's palm oil free. The plus side of palm oil, believe it or not, is that it is the most effective way to get vegetable oil, right? Rapeseed oil or canola oil is 6 times less effective than palm oil, and soybean oil, soybeans produce 10 times as little oil compared to a palm plant. So oil palms produce way more oil, so a lot more efficient at producing oil, a lot of bang for your buck. And there's been a lot of research recently into, that should say genetic alteration, not genetic medication. Oh my. Genetic alteration to further boost the yields of these plants and potentially reduce the need for cutting down more forest to increase the plantation size. But if we can reduce the demand for palm oil by not buying those products, and also maybe do some genetic engineering, that might help us out. Here's some stats looking at the palm oil industry, where it's grown, the area harvested, and the potential yields. And last thing on palm oil is that very recently, there's an article published about reclaiming palm oil plantations and restoring them in Malaysia. These conservation group bought a former palm oil plantation and started using it as a habitat corridor between two fragmented areas, planting native species of trees there, and trying to help threatened species move between these two different wildlife reserves, such as tigers and elephants and orangutans, wildebeests. And hopefully this paves the way for more restoration of oil palm plantations going forward, because we need to protect, this is supposed to be in quotes, another error. Wow, look at this. How pathetic. All these mistakes I'm making. Because we desperately need to protect the biodiversity and also help regulate the climate by protecting these rainforest ecosystems. And the second case study is soybeans. Soybeans are grown, a lot of the slash and burn that's happening in the Amazon is to grow soybeans, which are then used to feed cattle, which then are used to produce beef. So we're not even eating that soybean product, and it was having such a large demand and leading to so much deforestation that there was actually sort of this boycott, and they called it the soybean moratorium, boycott of soybeans that were produced on deforested Amazon farmland. So people just stopped buying them wholesale for the products that they're making. The companies stopped buying them, and so that led to a drop of deforestation by 70%. From 2005 to 2014, it prevented 3.2 gigatons of carbon dioxide emissions from occurring, which is about half of the annual U.S. emissions. And in more recently, in 2013 to 2014, soybeans accounted for less than 1% of Amazon deforestation. So this is an example of one way that you can, or companies can sort of regulate the market by refusing to buy products that are grown in unsustainable ways. And if we zoom in on this picture, we've got this giant monoculture here of soybeans, and on the edge of that is, or on the other side of that is a sort of a natural wild rainforest, and this edge here is what we call the edge of an ecosystem, and you can see some particularly interesting ecological patterns happening there. Those are something called edge effects. This is something we see frequently with forests and plantations and farms, and what happens is on the edge of two ecosystems, on the boundaries of two habitats, we see some changes in biotic and abiotic factors, right? So there tends to be more sun, more wind, more pollution, and more water right on the edge of the forest. There tends to be increased grazing, increased predation. Chances are that invasive species will have an easier time moving in, and this can have some pretty significant impacts on forest fires as well. So let's take a look at the forest fires in California, which have been going on forever, but have gotten pretty significantly worse in the past few years. And these forest fires, as I'm sure you've heard, have been quite damaging. I know some family friends of mine have had to evacuate their homes on multiple occasions out of fear for fires. And if you notice, in this picture, you'll see these sparks flying across the road here from one patch to another. This is an example of an edge effect because on the edge of ecosystems, you'll tend to see increased wind, which is going to help spread the fire quickly, right? Blowing these sparks across empty patches of like grass or road or whatever into the next patch of forest. So it's actually going to spread faster across these patches of grass than it will across the forest because the wind is pushing these flames and feeding in oxygen. But Connecticut also has a lot of patches. It's not just California. If you look at this map, it shows the average size of forest patches. So the darker color it is, the larger the patch. So in Greenwich where we are, there are pretty small patches of forest. So we see a lot of patchiness, a lot of habitat fragmentation. Why don't we see a lot of fires? I mean, there are fires in Connecticut, of course. If we look at the data, California in 2017 had almost 10,000 fires. Connecticut only had 97. In California, that was about 1.2 million acres, or 1.2% of the state's area, whereas in Connecticut it was 243 acres, which is 0.007% of the state's area. So there's definitely an increased amount of fires happening in California, but it can't just be due to these patches, right? Because California and Connecticut both have relatively patchy forests. And the reason it has to do a lot with California's climate, its ecosystem, and the anthropogenic activity that's been going on there recently. So in California, pretty rapid anthropogenic development, building of suburbs and stuff like that, has led to severe habitat fragmentation. You can see all these patches here, which is going to increase fire intensity because of those edge effects that I was just talking about. Fire will spread quickly across those patches. Additionally, due to climate change, there's been a hotter and drier climate, which increases the frequency of forest fires as well as the intensity. If everything's drier, it's easier for a fire to start. And in the 1940s, the fire suppression practices were basically saying, like, no fires of any kind. If there's a fire at all, we need to put it out. And what that meant is that any dead trees and grasses and stuff that died, instead of burning away like it should in the natural processes of California's ecosystem, it just sat on the ground. So you see this buildup of fuel, dead logs and grasses and stuff like that throughout the 20th century. Which was left a lot of fuel just sitting around, which is why they use oftentimes prescribed burns now to get rid of all that fuel that's just laying on the ground and reduce the intensity of fires. As the fires get more intense, it leads to more habitat fragmentation, which leads to more intense fires. You see a positive feedback loop there. There are some invasive species of grasses which have provided more fuel for fires, and there are some beetles, these nasty little beetles I'll talk about, which also have an impact on the fuel for these forests. So fires in general are pretty bad for climate change. They work in two ways. First of all, forests absorb CO2 and other air pollutants as well, like nitrous oxides and ozone. So when you burn a forest, all of the carbon that they've stored gets released because that wood is burning. But additionally, when you burn wood through a combustion reaction, you're releasing CO2. So not only are you losing a carbon sink, but you're also putting carbon dioxide back into the atmosphere, right? Which results in this change that we see where as climate change increases, we tend to see worse wildfires, and wildfires tend to exacerbate climate change on its own. It's another positive feedback loop. Here is an article about the invasive grasses I was telling you about. These grasses come in, they grow really, really rapidly, are selected species, and they create a lot of really dense biomass that dries out very quickly when it dies, which is great fuel for fires, allowing it to spread even quicker across those empty patches of fragmented habitat. And the beetle I was telling you about is called the mountain pine beetle. This is what it looks like. And the larvae will burrow into a type of tree called the lodgepole pine, and it can ultimately spread a fungus that will then kill the trees. But recently they've gotten a lot worse. First of all of these lodgepole pines are relatively the same age because of monocultures, which means that they're all susceptible to the beetle, because the beetle only likes older trees. And additionally, the beetle is expanding into ranges that it normally didn't live in. And that's got to do with global warming and the beetle's ecological tolerance. Usually they die when it gets below minus 20 degrees Fahrenheit. But because of climate change and global warming, the Rocky Mountains where it lives are starting to warm, so they can actually go into areas that were formerly too cold. So their range is expanding. So what does this have to do with fires? Well, the lodgepole pine requires fire in order to spread its seeds. So the pine cones don't open until they've been exposed to high heat. It melts the wax on the outside of the cones. But ultimately what the beetle is going to do is it's going to provide more fuel for these fires. Right? So like I said, the pine germinates best after fire. So we have a fire coming through. All of a sudden you've got all these pines germinating that are growing. But then the beetles come through and they cause all the trees to die, or a lot of the trees to die, by spreading this fungus. And when these trees die, they burn really, really well. And so the fires are going to wipe out any seeds, destroy the topsoil. The fires can spread to the canopy and bounce from tree to tree. So these lodgepole trees tend to burn really, really rapidly. What we need to do about that is try and counter the impacts of the beetle, selectively cutting down trees that are impacted by the beetle, and manage those pests. We'll talk more about pest management later in the year. Okay, and last component for this. So these solutions here that apply to the beetle, what else can we do to help make our forestry practices more sustainable? And we need to focus on reforesting areas, and steering away from clear cutting as much as we can, trying to reuse wood, reduce our consumption of wood, but also reuse the wood that we do have, set up preserves through national parks, national forests, and wildlife preserves to protect these trees and manage the way that they are harvested, if they're harvested at all. And we need to change the way we think about fire management. Monocultures are really vulnerable to fires because if there's no fire-resistant trees in that monoculture, the whole thing's going to go up. But if you have what's called a mosaic forest, it might be a little bit more resilient to fires. But also using things like prescribed burns to clear away a lot of that dead fuel for fires. And I'll show you a video in class about sustainable logging practices. Sometimes they can grow forests with trees that are all different ages, and focus on managing for the long term, maintaining that biodiversity, thinning out the trees so they don't get too thick, because if they get too thick together, then fire can easily spread from the top of one tree to the other. So you don't want them to grow too close together. Although these practices are hard to compete with the large-scale economic clear-cutting practices, right? But if we're using things like horses to pull logs or pulling logs out with helicopters, that's going to lead to fewer logging roads, which will decrease the impact of deforestation substantially. And the last case study for you, and last slide for you, is the Menominee Indian Reservation in Wisconsin. It has the most sustainable forestry practice in the world. You can see their reservation here by the straight, thick line of green, because this is all forested area where they live. And they cut their lands in a very long-term cycle. It's over a century long, and they have actually managed to increase the amount that they harvest each year while also maintaining the health of the forest. So they're not shooting themselves in the foot by harvesting these trees, and they do that by focusing on the maximum sustainable yield, right? Not harvesting too much. They keep an inventory of every single tree in the reservation, so they know which trees are doing well, which trees are healthy, how old each tree is, and they're only taking mature trees and focus on maintaining the biodiversity of the ecosystem. So this population, the Menominee River Indian Reservation, is a really great case study to look at how we can manage our forests in a sustainable way. Okay, that's all I got for you. Bring your questions to class, and I will see you then.